Welcome, everybody. My name is Andrea Moro, and I teach at the University School for Advanced Study, USS in Pavia. I study the relationship between the structure of languages and the brain, and this is what I'm going to talk about now. In fact, um, I would like to highlight the notion of boundaries of Babel, that is, of the limit of variation among languages, and the consequences that it has on logic of the brain via the notion of impossible languages. I have two premises I would like to highlight before starting my discussion. The first one is, so to speak, to start from this kind of spectacle we have, starry nights. What we literally see here is the little dots corresponding to planets, stars, galaxies, and our brain instinctively tries to join some of them, producing figures that we call constellations. There are very famous ones. For example, as you all know, the Ursa Major, the so-called bear that can be seen, certain representation of the starry night during the brain. What our brain receives is just dots, and we are responsible for constant galaxies. The reason why I'm saying that is that when we study language, we practically face ourselves in a situation similar to this one. We have scattered facts around us, constituting the universal language. Some of us propose to join some of the facts, considering a certain images that could be not only beautiful, but maybe useful. But we have no guarantee that we're joining the right dots. And this is what we do when we study language. And I would like to highlight that at the end of the day, the reason why one constellation can be assumes to be useful rather than the other is done on the base of the predictions that you made when you consider a certain phenomenon. Actually, we have to stick to the fact that our eyes see stars and it's our brain that's able to see this constellation. The second kind of premise that I would like to address before going into the core part of the argument that I would like to develop here tonight is a different kind of premise. And it's represented by the idea that to understand what is possible, sometimes we need to explain why something is impossible. This is not a canonical way of regarding science. Science is typically the discipline that tries to understand what is there of reality. But some science part of the reality insists on a whole in a grid of expectation that is something missing from what we see. And understanding the reason why something is not there is probably one of the most fascinating way of looking at at a reality. And I think that this can be done also in linguistics, especially when it comes to the relationships between language and the brain. Now, let's start with what we know about language and the brain. We all know that language depends on a specific brain activity, and we know it at least since the second half of the 19th century, ever since a person called named Monsieur Le Borgne went to Paris and knocked the door of the hospital, and he was unable to use his language. He was only able to use one single word, and in fact one single syllable, tan, and to repeat it. So this person was named Tantan. After he died, the surgeon who was in charge of this patient opened the skull, and what he found was what he called a ramollissement, a softening of a tissue in the frontal lobe, in the left inferior frontal lobe. This person named Tantan was in fact the object of observation of a very famous doctor whose name was Broca. And in fact, the area that was damaged in Tantan's brain is ever since that time called Broca's area. Now, the question that we're going to face here is whether the formative grammars depends on brain structure. That is, not only language as a kind of a monolith that is of a unitary phenomenon, but whether specifically the format of all the roots that form grammar depend in a sense on the brain. And this is where obviously the notion of impossible languages will be interesting. There is one interesting thing to notice, though. We are not Our knowledge of the biological foundation of language is kind of late, and not only because we lack animal modus, but also because ideology contrasted the search in biology in a very interesting and dangerous way. Let me highlight how this dangerous relationship established by quoting a passage from the introduction of a very famous book by Eric Lenneberg, who was a neuropsychologist at the Massachusetts General Hospital in Boston. He once said in this book, "A biological investigation into language must seem paradoxical, as it is so widely assumed that languages consist of arbitrary cultural conventions." In other terms, if everything is arbitrary and cultural, there is no way we can discover anything interesting in the brain. It would be like trying to find the reason why the yellow light is used in traffic lights, to wait, or the red one to stop and the green one to go. We could actually have the same traffic light with inverted colors to the extent that they are visible and have a good contrast that can be adopted. Nowadays, things are completely different. If you buy one of the most one of the best sellers in cognitive neuroscience, which is the 5th edition of Principles of Neuroscience by Eric Kandel, a Nobel Award, you would find that in the first chapter, everything is already taken for granted. A language has very deep biological roots, and that is something which has to be established. Of course, there is a part which is completely arbitrary in language, which is the so-called Saussurean arbitrariness, that is the link between meaning and sound. But this is something different. What I'm talking about is the very fact that the structure or the rules themselves are not completely arbitrary and cultural conventions. Looking at language with that kind of ideology was in fact functional to something that we could actually call the new Babelism, and which is very well represented by the following sentence by Jews that was expressed in his reading in linguistics in 1957. Languages can differ from each other without limits and in unpredictable ways. Actually, this was like, re-establish Babel as a chaotic system, one where you cannot find any rule, any governing pattern, and where everything, is acceptable. And if this is true, of course, even with respect to the problem of finding something in the brain that can control languages, is simply unuseful, because languages are not controlled. They should be, completely unstructured, and they can be, realized without limit and in unpredictable ways. This was actually deeply entangled with a scientific technological project, which we could call the statistical learning. And in the 50s, this was especially cultivated in many centers of research, especially in one, the mythical laboratory of electronics at MIT. And to give you an idea of what the atmosphere was in that lab, I'm going to quote another thought signed by Yoshua Bar Hillel, a logician who was an eyewitness of that period. There was an ubiquitous and overwhelming feeling around the laboratory at MIT that with the new insights of cybernetics and the newly developed techniques of information theory, the final breakthrough towards a full understanding of the complexities of communication in the animal and the machine had been achieved. As you see here, you have machines and animals. Humans disappeared. This is extremely interesting, because that way of considering statistical learning has made, what is specific of human language completely irrelevant. There is a tentative nowadays to reproduce that atmosphere due to the acquired capacity of calculus that new machine have. And in order to understand the situation, we still have to keep separate what a machine can do while simulating a behavior and what a machine can do while trying to understanding the actual functioning of the human brain that have to be separated, otherwise a confusion comes out. But what is interesting at that point, the citation, the quotation here from 1970, but it reflects what was happening in the 50s, is that whenever science expresses the idea that everything is completely understood, as is here, as it's said, as Barilal says here, a final breakthrough towards a full understanding. When science says that we have a full understanding of something, 100% of the time we have to start from scratch. This happened in physics when in the end of the 19th century they said, we understood all the physical rules of the world, just have to be sure that we fixed the final decimals in the final ciphers in the in the gravitational constant and the great constants of physics. And then people were completely overwhelmed by the discovery by Albert Einstein and Max Planck of new world, basically starting from some very specific small experiment that had a devastating effects on the orthodox theory circulating. Something similar happened in linguistics as well. In that case, it was one person who put together three different phenomenon, correlated but independent: complexity of languages, uniformity of languages, and spontaneous acquisition. And there is a mirable synthesis that was expressed in his own word. The fact that all normal children acquire essentially comparable grammar of great complexity with remarkable rapidity suggests human beings are somehow specially designed to do this, with data handling or hypothesis formulating ability of unknown character and complexity. And this was the thought expressed by Noam Chomsky in 1959. As you see here, not children come back, that is, humans come back into the scenario as the protagonist of the expression of language. And then we have the other term, which is designed. This is extremely important because for the first time, what is said here is that human beings do not actually perform a kind of a generalized statistical activity on language stimuli. They are designed to do so. But of course, the unknown character and complexity of this design is still under inspection by scientific research, although we now know a lot more than what we used to know in the 50s, especially with respect to the relationship between the brain and language. So we substitute the old vision, languages can differ from each other without limits in unpredictable ways, with a new one. Language is a set of specific values for parameters in an invariant system of principle. Difference invariant system. This is the possible opposite way of looking at language. And there are empirical and theoretical reasons to assume that the second one is much closer to reality than the first one. One other kind of a general premise is what to look in language to try to understand the relationship between language itself and the brain. Well, language is a universe. Language is made. You can actually study many different things in language. You can study sound of language. You can study the meanings. You can study the history of language. You can study morphology of paradigms. You can study how you use language to pray, to make irony, to describe, to order, to invite. It's a real universe. But as in all universes, what you can do, you can adopt Husserl label for a way of looking at things that he called the Galilean style of research, namely one where you select one factor and you try to idealize the world, reducing to the minimum the confounding factors. You can do that in physics, of course. For example, if you think that friction is not existent, or you want to study the dynamics of bodies, and you can do that in language if you concentrate on syntax as if the other components were not there. Syntax is not only very, very interesting because it's kind of not easy, was relatively easy to describe, syntax at least when it comes to word order. But actually, it's interesting also because syntax appears to be the border between the, the kind of code of communication of all animals and humans with respect to the one of humans. This is not a breakthrough new. It's news. It's just something that was that people already knew ever since the early 17th century. In fact, this was described by Descartes himself in his Die Cours de la Méthode, where he said, there exists no person who cannot put together words. Put together is syntax, in other terms. Put together words, and by these compose a discourse to express his thoughts. On the contrary, there is no other animal so perfect or posed in such a favorable condition to perform the same task. Now, this is clear, but as all scientists, we wonder if this was really tested. That is, did people test other animals? Did they find out that they don't have syntax? Syntax is easy to describe in a nutshell. Take three words, like, John killed Peter. You have three words, John, Peter, and kill. John killed Peter expresses one situation. Peter killed John expresses the opposite. Same words, different syntax, different meanings. Now, it seems to be there is no animal that is able to do the same thing. Again, did people really check on that? Of course, we have to do some generalization when we try to understand what happens in the world. That's always the case in science. Newton didn't check all the apples and to find out if one of them didn't fall on the ground. And similarly, we cannot do that with all animals, but we can do significant testing on special cases. One of the cases is chimps, that is, those primates that share with us not less than 98% of our genomes. That was done, in fact, in the 70s in New York, where a group of people headed by Tom Bever, now in the University of Arizona with Noam Chomsky, decided to train a chimp to human language. And it turns out that the chimp was able to learn words, up to 128 words, which is a lot of words. But when it came to constructing sentences, out of 119,000 sentences, none of them was possible, was distinguished from the other because of word order, as in Peter killed Bill or Bill killed Peter kind of sentence. We see here a picture of Laura Ann Petitto, where as a young scientist who was trying to train this chimp, and actually she using her hands, because one of the the smart tricks that this group used was not to use sounds, because it could have been that the animals were not able to express language because they don't have the same articulatory apparatus as we have. So they use sign, because signs was very simple to be used by the chimp. And in that case, that avoided the conclusion that it could not learn the language because of the production of sounds. So the conclusion is that, yes, someone tested other animals, not only this one, but apparently they can get the equivalent of words, but they not get any equivalent of what we mean by syntax. Now let's go back to the very idea we had before, that is, why are there certain rules missing in the languages of the world? And we can kind of formulate a very simple question concerning that. And the question is the following. Again, why aren't all conceivable syntactic rules realized in the languages of the world? Let me put it very simply. Suppose I give you a dictionary. You can design some combinatorial rules among the words of this dictionary. There are very many kinds of combinatorial rules, practically infinite, but only few of them are realized in the languages of the world. Why is it so? Let me give you a simple example because I don't want it to be too metaphorical. I just want to give you an example of what I mean by conceivable but impossible languages. And I call it the global inversion. We all know that in English, we do it even instinctively. If you have a sentence like John is happy, and want to turn it into an interrogative sentence, the sentence comes out as, is John happy? That is, we simply move or displace the copula is from its original position in the affirmative sentence to the front one. In fact, if we number the sentences, we have that instead of the order 1, 2, 3, we come up with the order 2, 1, 3. Now, that means that our brain is able to permute the position of a certain word in a string. But it is never the case that given a sentence like he asked to go home, you can get another sentence by saying home go to asked he. That is, given a sentence of 1, 2, 3, 4, 5 words, you never have general rules. The global inverts all the words, and gets you 5, 4, 3, 2, 1. This is never the case, but the rule is simple and it's conceivable. Of course, it's conceivable because I conceive it, and it's simple as well. If we decide to use it in our secret conversation ever after the finish of this talk, you could actually use it. Why is it never used? Well, one could assume a paleontological, so to speak, answer and say, well, this absence is simply explained by assuming a common historical origin for our species. In other words, suppose you have a world, a map of the world where you see this is Africa, and you have dark black arrows. We originated all here by a couple of monkeys, one of which was a mutant, either the female or the male, and had this, incredible mutation that gave her or him language. And then we migrated as little ants all over the globe, hopefully trying to preserve it even in the next years in the future. We're not completely sure if we're able to do that or not, but certainly one hypothesis could be that those rules that are missing now in the languages of the world are rules that were missing in the first language that was used, and then copying one language on the other, the answer could be simply historical. The first one didn't have those rules, then all the last languages don't have these rules. This could be an answer, but it will be not particularly interesting. But we can actually perform an experiment and try to find if we have an alternative. The obvious alternative is that it's not because that rules, conceivable simple rules, were not contained in the original language, but just because our brain is not able to compute them. Suppose we were analyzing the way that people eat, the kind of food people eat. All over the globe, people eat very different kind of food. There are those who eat meat, those who only eat vegetables, those who can eat insects. And normally in the Western country, we don't eat insects, but the majority of people on the globe do eat insects. And there is a consistent and considerable variation. It's never the case, though, that there is a group of people that drink gasoline, and it's not cultural. This is just because we're not designed to drink gasoline. So our question in linguistics terms is, are we designed to acquire any possible rules, or are there any rules that in a sense cannot be digested by our brain? Are there rules that have a gasoline ingredient that makes them unacceptable? Well, we designed an experiment with that. And I did that with a group of scholars and scientists and neurologists at the University and Hospital of Hamburg and Jena. And I repeated it actually in other centers, including the hospital, University Hospital in Zurich. What is the revolution of neuroimaging? Considering what Dr. Broca had to do, wait for a patient to die before opening the skull and recognizing the ramollissement, the softening in this brain. Nowadays, but we can measure blood perfusion and blood flow either with the positron emission tomography, the PET, or the fMRI, the functional magnetic resonance imaging, and we can get information on the local metabolism of brain activity of in vivo and healthy subjects. It is as the blood is something like the fuel of cellular metabolism. If you observe that corresponding to a certain task, you have is the amount of of blood in certain area or a certain network in the brain is increased, you can relate that area or that network to that activity and formulate the hypothesis that this is connected directly to the activity. Of course, there is no immediate data. The neural activity is proportional to the oxygen level, but just because of the fact that all the brain needs oxygen and blood, you cannot simply put a person inside of a machine and expect to have direct information. If you ask her or him to count, you don't have the network for math or whatever, because the brain is and it has a lot of tasks, including those that keep your body in a fixed position when you are in the machine. So how can you explore the relationship between languages and the brain? How can you answer the question as to why aren't certain types of syntactic rules realized in the languages of the world? That, remember, the absence that is challenging us. Well, you can kind of reproduce the situation in the following way. You can actually teach a group of monolingual German, as we did, speakers, a micro-Italian, including possible versus impossible rule, and see if the brain behaves in a different way in respect to when the person manipulates and adopts, uses a certain rule which is possible versus the rule which is not possible. And you can analyze that with fMRI. I can give you a concrete example of the rules by showing one of the pictures that appear in the paper that I'm citing here. So here, the German speaker, to say I eat the pear, says something like ich esse die Birne, whereas in Italian, for example, while learning micro-Italian, I had to learn that you drop the subject. You don't necessarily say I eat the pear. You can say eat the pear. And as an impossible rules, we gave, among others, a global inversion rule. So a sentence like Paolo eats the pear, Paolo mangia la pera. We had pera la mangia Paolo, pear that eats Paolo. Of course, as I said, they did not know which rule was possible as impossible. And then we sent the paper to the journal, and it came back by saying, well, we like your results. Of course, we found some results, but as a matter of fact, that could be interpreted as the very simple fact that Italian and German belong to Indo-European languages, and the impossible languages may belong to a different kind of family of languages. And this forced us to redo the same kind of experiment with a different language to exclude the typological similarity played a significant role. Another group of monolingual German speakers was taught a micro-Japanese, including possible versus impossible rules, because Japanese does not belong to the Indo-European languages, and so any difference, if we didn't see any difference, we were allowed to assume that the similarity between Italian and German on the one hand and on impossible rules on the other was generally linked to the fact that the languages were impossible and not that they belong to similar or different families. So here is the rules that they learned. Again, Paul isti bene, and they had to learn that in Japanese, you have the subject, the object, and the verb. So you say the equivalent of Paul va, nashi o, the pear, eat taberu. Paul va, nashi o, taberu. And then they learn also that with a global inversion rule, the interrogative construction gives you, again, you can read it backwards, Paul va nashi o taberu, but the rule was one such that the sentences has to be global inverted, giving you taberu o nashi va Paul. And then we had the results, and the results were neat, and then I am happy to show them to you immediately. The paper was published in Nature Neuroscience some 20 years ago. And here is the result that I tried to summarize with a sketchy diagram. So first of all, we have the data concerning the accuracy. That is, we can we can measure how better they get in learning the rules while they study these two languages. The far you go from left to right, the better you are. Then we can actually correlate the accuracy with the activity in Broca's area, namely one of the areas in the brain that within a complex network takes care of the computation of syntactic rules. And we can measure blood flow in Broca's area by using fMRI. Now we have the two ingredients, accuracy and blood flow. And we can compare the reaction of the brain with respect to possible versus impossible rules. So in the case of possible rules, we had what one could expect, namely the better you are, the more your Broca's area calls for blood. That is, it's activated and the brain instinctively recognizes them as rules of language and so treats them as rules of language. And then the network that refers to languages, to language capacity, to language faculty is activated. With impossible rules, we had what we hoped to see, but we didn't even dare dream. That is, the better you get, the less Broca's area is activated. The brain instinctively recognizes impossible rules and treats them as something which is non-linguistic, which is different from the linguistic input that it was expected. In other words, we can actually conclude that by considering the experiment that I show you, the existence of impossible languages is not due to arbitrary cultural convention, to just use Lenneberg warning words, but to the neurobiological architecture of the brain. This is why in the Principle of Neuroscience nowadays, in the first chapter, you would actually find these as, one of the base results that you can adopt to study the foundation of a biological foundation of language. In other words, the boundaries of Babel do not only exist, they are expression of our brain. As a consequence of the biological hypothesis, we had a very neat and strong restriction on logic and grammar. When we talk about logic and grammar, though, we have to be very careful because this is one of the kind of topics that can be very difficult to treat. We can start with the idea of meaning of a sentence, which is it was a huge argument. There is no unique answer, of course, with the idea of meaning of a sentence. But one possibility is to characterize the conditions which allow us to say if a sentence is true or false by using self-theoretical tools. So let me give you a very simple example. What's the meaning of the sentence, eagles fly? Well, you can actually adopt self-theoretical tools and say that given E as the set of all eagles, and given F, the set of things which fly, the sentence eagle fly corresponds to the representation when E is a subset of F. That is, there is no such a thing as an eagle, which is outside the set of things which fly. Obviously, eagles don't fly correspond to the representation where the intersections of the set of eagles and the set of things that fly is equal to the empty set. In other words, there's no such a thing as an eagle who can actually also fly. This is, so to speak, the basic tools we need to understand one of the major striking facts concerning logic and grammar that is nowadays considered as the base of our reflection of the nature of human language and converges with the neurobiological experiment that I was talking about. And this is the logical property I want to talk about. Suppose you have a sentence like, some men run. What's the meaning of the sentence? Let's use again the set theoretical notation. Ems is a set of men, R is the set of things which run. The sentence, some men run, has this meaning. The intersection of the subsets is different from zero. That is, there is at least some elements of the set in M that are also a part of the set R. Now consider the following sentence. Some men are men who run. Actually, we do know that if some men run, it's true. It's also true that some men are men who run. It's obviously the case the second sentence is, is marginal, but it's still grammatical. And if the first one is true, the second one is true as well. Some men are men who run, some aren't, simply as that. Now, what is the representation of the meaning of the second sentence? Using the same set theoretical notation, we arrived at the following formula, which is by no means simple. It says that the intersection between the set of men and the intersection between the set of men and the set of things which run is non-empty. Well, we can actually observe one important fact and say that not all relations have this property, and this property can be has been called and can be usefully adopted, the term can be usefully adopted as conservativity. Whenever a relationship is conservative, it's true. A relationship like the one I showed you between the element and the intersection between the element and the other set is conservative. Now, as you see here, conservativity is by no means a very easy to get property. But I think that the fact that it's not completely easy is part of the explanation I want to use. Let me go throughout a few considerations on the consequences of conservativity. Conservativity is difficult to describe, as we just saw. It's not intuitive at all and cannot be deduced from facts. If you open a window and see outside, you see many relationships between objects there, but it's not obvious which one is a conservative one. If this is true, this has a powerful implication on language acquisition by children. Because for children to use it, and children use the word like some, it must be the case that it precedes experience. In other words, that is biologically determined. But if it is true, then if it is biologically determined, it follows that conservativity must be valid in all languages. And this is exactly the conjecture that Barwise and Cooper formulated in 1981, a powerful one which, as you see, converges with the experiment on possible and impossible languages by arriving at the idea that the structure of languages is deeply and profoundly rooted in the brain in such a way that you should see the relationship the other way around. It's not the case that languages are like softwares that freely run on a hardware, which is the brain. Rather, the brain is it's an organ that expresses the software that can run on him and imposes restrictions that are biologically determined. And they can be seen by using impossible languages, as we saw before, and they have a very important consequence on the notion of logical grammar. And in fact, it is completely compatible with Barwise and Cooper generalization. There is one single important fact that I would like to highlight here. Since all children are in fact endowed with the capacity of learning any possible language, there is no children don't have any influence on the language that their parents speak. If a child is adopted by another community, she or he immediately learns the other language with no difficulty. Now, it means that we have in our brain potentially it's like a STEM brain or a STEM mind. And in other words, we can contain all the possible languages. Is it contradictory with the idea of biology? Isn't biology economical? Not at all. Look at this picture. I used this picture many years. I've been using this picture for many years, but nowadays it's obviously, kind of unexpectedly interesting. Our body not only interprets the information coming from the sentences of the people who speak to us, but also has to interpret the information of antigens that gets into our body and are potentially dangerous. Now, as with languages, where before any experience we were endowed with the capacity to learn any grammars, maybe someone which we never learn, with the immune system, we're endowed with an abundant repertoire of antibodies which may counter diseases we will never be exposed to. It's like, it's not a contradictory with the idea of biology that we have all languages in our mind, because the same thing of abundance happens to be true in the case of the immune system. Is this sci-fi? Is this a very rhetorical artifact I'm using? Well, no. The person who had the idea that the immune system works the same way as language acquisition, for this idea, got the Nobel Award. His name is Niels Jerne, and the first person he cites in his ceremony, in his speech where he was awarded the Nobel Award, was Noam Chomsky. And one of his sentences, very interesting, is the following one. I find it astonishing that immune system embodies a degree of complexity that suggests some more or less superficial, though striking analogy with human language. Besides everything, what I would like to show you, and I offer here possible, perhaps unified and much more detailed perspective on language, mind, and brain in a paper written with Angela Friederici, Noam Chomsky, Robert Bobeck, and Johan Böhlhuis. And finally, we can actually admit that brain studies and linguistics prove that impossible languages are biologically constrained, suggesting new questions on evolution and on the specificity of human nature. As if the idea of the boundaries of Babel was a literally new way to understand how we evolved as humans and why it comes that we have such a marvelous gift as syntax to express infinity. And remember that syntax is, structurally speaking, in common with two other domains, that is music and math. So music, math, and syntax in grammar are probably the real fingerprint of real humans. Let me just finish with a kind of a prequel in a sense. I like to cite this for several reasons. One of the reasons is this year, 2021, is the anniversary of Dante Alighieri's death. And Dante thought about language in a way that no one did. And here is a page of his De Vulgari Eloquentia that where he discusses the nature of language. And there is an interesting passage where he says that there are certain people who consider themselves as having the best language ever, and the best language, it's not only the best, but the one that was speak first. That sentence can be translated in English as follows. Pietramala is a great city indeed. In fact, it's a small village outside Florence, the home of the greater part of the children of Adam. For whoever is guided by such an obscene reasoning as to think that the place of his birth is the most delightful spot under the sun, may also believe that his own language, his mother tongue, that is preeminent among all others. And as a result, he may believe that his language was also Adam's. Now, believe it or not, you may think that this is a repertoire of history, but the very idea that the language you speak may be the best and the civilization speaks that language is the best, and that access to a language can only be done if you belong to a certain race, was the origin of the Aryan race and of the 20th century Shoah. So one has to remember that the origin of modern racism is deeply rooted with the idea that there are better languages and ingenious languages. There are no better language than the other. All languages are equivalent. There may be better comments to languages. For Greek and Latin, for example, we have cathedral of thought concerning reflection of those languages. So after all, reflection of language not only have a deep importance on our understanding on the nature and the evolution and the position of humans in the universe, but they also should be warn us as to whether any form of violence and racism should be suppressed by reconsidering the role of language in a culture. Well, this is all for everyone who is interested in impossible languages. There is an MIT press book, which is Impossible Languages itself. Then I want to use another quotation by a person who was simultaneously a professor of mine and a colleague. I had no success in both roles as a pupil, as a colleague, but he once told us that those things about which you cannot theorize, we must narrate. So I took the liberty to talk about impossible language by costing a rule. And you now obviously understand what the joke is. And Il segreto di Pietramala, the secret of Pietramala, is nothing but the same theory, but rendered in a narrative way. And so let me thank you and grazie for having attended this talk and for the people who invited me here to give this talk. Thank you.